Before we move on to the video, if you are looking for more LEED study material, please do not hesitate to contact me on my email and on my LinkedIn. In addition to the material, I have also developed a file in which I have put all the credit categories with their respective names, adaptations to which they apply, their description, their details, furthermore required documentations, formulas, and the standards they follow in a tabular form and color-coded. And all the important terminologies related to that credit categories are stated below. Feel free to contact me and I'll be more than happy to share all with you. Credit category Indoor Environmental Quality, 16 points for all adaptations except for core and shell, which has 10, and retail 15. Now, the reason core and shell has less number of points is because it deals mostly, this indoor environmental quality deals with the ventilation, and it is with the HVAC system. So in core and shell, 40% of the GFA is unfinished because it is for the future tenants. So you will see that so many credits are excluding core and shell. Now, what is indoor environmental quality and why LEED focuses on it? It relates to the conditions inside the building and the impact of those conditions on occupants' health, comfort, and well-being. This is something interesting, that as per the Environmental Protection Agency, people in the United States spend approximately 90% of their time indoors, where the concentrations of some pollutants are often 2 to 5 times higher than typical outdoor concentrations. So if LEED is taking care of all the aspects of the building, and the triple bottom line is people, planet, and profit. So we have taken care of planet and profit. Now for the people where they spend 90% of their time, which is indoor, inside the building, so LEED has divided these prerequisites and credits to fulfill the goals of sustainability, green building, and for the betterment of its occupants. So now if you see that there are 3 prerequisites and the remaining are credits, 1 prerequisite is only for the schools, and there are 4 credits in which core and shell is excluded. Let's see one by one in detail. Prerequisite number 1, minimum indoor air quality performance. This talks about the threshold of the air quality inside the building. The intent is to contribute to the comfort and well-being of building occupants by establishing minimum indoor air quality. It basically deals with the ventilation and monitoring systems. And there are some requirements that are to be met. Now there are 2 types of ventilation system. One is natural and one is mechanical. As per the figure, you know, the natural ventilation is like when you do not have any permanent HVAC system to deal with the ventilation. If you recall your early days science lecture, the warm air goes up. So this is the same concept, that it works on the pressure difference or the temperature difference. The cold air comes in and the warm air that has to go out from this space. So this is the natural ventilation where you do not have any mechanical or HVAC equipment in place. The second one is maybe more familiar, where you have heat ventilation and air conditioning system. The cold air or hot air is supplied, and then the return air is calculated, filtered, sometimes reused, sometimes it is ventilated in the atmosphere. So these are the 2 systems, natural and mechanical, and there are some monitoring standards that are to be followed that we'll see in the next slide. Since the prerequisite deals with 2 things, ventilation and monitoring, and we have seen we have 2 types of ventilation, mechanical and natural. So let's see mechanical first. We have option number 1, where we have to follow ASHRAE 62.1-2010 standard, or the local equivalent for mechanical and mixed mode ventilation. Mixed mode is when you have the combination of both. You have certain areas in the building that deals with natural ventilation systems, and the other where mechanical ventilation is used. And this is to establish minimum outdoor air intake flow. Outdoor air has to come in, processed or unprocessed, and has to go out. For option number 2, for the projects outside US, they may follow a different standard, that is CEN standard EN 15251-2007. Unfortunately, we cannot go into the details of the standard, but you have to remember the name of the standard and the clause or the addendum number. Now for the natural ventilation, you have to follow the same 62.1-2010. but there is CIB-SE AM10 that is needed because you have to show or to confirm if the natural ventilation is the right strategy for your project or not. If it depends on the climate. In certain climates, natural ventilation cannot be used. For example, the natural ventilation cannot deal with the humid climate. It cannot cater humidity. So you have to use the mechanical ventilation system. So in certain climates where the weather is harsh, whether it is too cold, whether it's too hot, in that case, ventilation, natural ventilation might not be the effective strategy for the project. So if you are using ventilation naturally, it should be confirmed by CIB-SE AM10 that it is the right strategy. Now coming to the monitoring. For the mechanical ventilated spaces, we have different strategies for monitoring. Let's see what are these strategies. So the first strategy for mechanical mode ventilation system is when you have VAV systems installed or variable air volume, then you have to monitor the direct outdoor intake, and it should be monitored with around plus minus 10% accuracy. And if you have put a set point which is based on your design, based on your requirement, based on the climate, or based on the weather, then if it varies from that set point around 15%, then it should sound an alarm. The alarm should be installed. So the second is for constant volume systems with current transducer to balance the design airflow, and this should be as per the ASHRAE 62.1-2010 standard, which will come again and again in this credit category, and in other slides we are going to see. Now the monitoring for naturally ventilated spaces. You know that naturally ventilated spaces works on pressure difference or temperature difference. So the incoming air is from usually from windows or from louvers. So in case these windows or louvers, which are critical when it comes to the naturally ventilated spaces, they should be alarmed if they are closed, because they will disturb all the ventilation process. And you also have to measure the exhaust airflow, in this case with the plus minus 10% accuracy, and an alarm if it goes beyond the set point by 15%. Now the third thing is that you have to install CO2 sensors. Let's understand why we need the CO2 sensors. Carbon dioxide is produced when people breathe. So each exhaled breath by an average adult contains 35,000 to 50,000 parts per million of carbon dioxide, which is 100 times higher than the amount typically found in the outside air. So if building ventilation system is not adequate, accumulated CO2 can cause health issues. That's why we have to install CO2 sensor, and that should be in the breathing zone, that is 3 to 6 feet above the floor, and it should also have an alarm if it goes beyond 10% from the set point. You can see it in the figure. This is how a carbon dioxide sensor look like, and it should be in every climate zone, by the way, for the building spaces. Let's have a look at some adaptations, inclusions and exclusions, or the extra requirements. For core and shell project, they should also take into consideration the requirement of the future tenants, because they don't know right now 40% of the area is unoccupied or not final, because it has to be taken care of by the people or the tenants that are to be renting out. So you have to consider the future tenants for core and shell projects. When it comes to the healthcare projects, usually the healthcare projects have stringent measures, and the requirements are generally high. So it should determine minimum outdoor air intake as per another ASHRAE standard, that is 170-2008 and 2010 guideline. For the data center projects, requirement apply only to occupied spaces. So the because generally not the same amount of ventilation would be required for equipment. So it is basically for people. So it would apply only to data center projects where there are occupied spaces. Warehouse must meet either mechanical or natural ventilation. The idea or intent is similar, that the ventilation or strategies which we are implementing is mainly for people. So warehouse, there are materials and storages, so they can go for either ventilation requirement. And for the housing projects or dwelling units, there might be some additional requirements. It's not to be discussed here in detail, but we have to know that there are some extra requirements for housing. So this is the prerequisite, and for the documentation we have to confirm and calculate that all standards that we have seen for the regular ASHRAE 62.1-2010 for healthcare, this additional standards are met. And for monitoring, a control drawing showing monitoring devices for natural ventilation, if you have CO2 sensors, or if you have exhaust airflow sensors, and all the required devices. Now, Chartered Institute of Building Service Engineers flow diagram process of the project to be submitted for natural ventilation only. This is for you to search. It is interesting, but it will take too much time if we discuss here. But that is the reason I put the full form, and you can search on the internet what does it mean and why it might be required for natural ventilation. Credit number 1, enhanced indoor air quality strategies, 1 to 2 points in all adaptations. If you compare the intent of this credit with the prerequisite intent was to contribute to the comfort and well-being by providing minimum indoor air quality. But in this case, with the enhanced indoor air quality, we have to take care of the well-being of building occupants by improving indoor air quality. This is if the requirement here is to protect the occupants by providing them the atmosphere, or providing them the air quality in which there is no potential of hazardous particle entering the building. So you have to prevent the hazardous particle, or you have to prevent the dust coming from the exterior to the inside of the building. So there are certain strategies that you can put, and these strategies are based on the ventilation system you have applied in your project. So let's see the option number 1 is enhanced indoor air quality, 1 point for all adaptations based on ventilation type. So the first strategy is to secure the entryway systems, and this is for both mechanical and natural ventilation. And also we have a third one called mixed mode, which is mixed ventilation, is the combination of mechanical and natural. So you have to install at least 10 feet long entryway system to capture dirt at regularly used entrances. And how to capture the dirt? You could place grates, or you could place grills. You might have seen in the buildings where there is this applied, and you might have noticed why it is. Now you know that it is for the entryway system, preventing the dirt or any hazardous particle to enter the building. So you put a small space from all the functional entrances, so that if there is any contaminants, they can be sorted out before they enter into the building. And these carpets or grates or grill has to be cleaned at regular intervals, I think minimum weekly. So the interior cross contamination protection is for mechanical ventilation system, that it must sufficiently exhaust each space where hazardous gases or chemicals may be present, and this exhaust should be minimum 0.5 CFM or cubic feet per minute per square feet. Now in certain parts of the building where you have if you have powder copying, or if there is any other potentially hazardous gases that are present, so in these areas you have to provide extra exhaust with this minimum requirement of 0.5 CFM per square feet. Now there is filtration. This is also for mechanical ventilation system. Each ventilation system that supplies outside air, if you have air handling units, that is taking the outside air and putting it inside, so it should have a minimum efficiency reporting value, or MERV rating. You can also search what are MERV rating. It goes from 8 to 13 and or higher, or maybe more, as per required by the standard. So we have entryway system strategy, we have interior cross contamination protection, and we have filtration. So let's see what are the other strategies and other options. Another strategy is to have design calculations for both mechanical and ventilation system, and the standard is by Chartered Institute of Building Service Engineers, and these are the standard clauses or the addendas. If you have searched for this CIB-SC before, maybe it will elaborate here further. You can see the filtration, the MERV filter we are talking about before. This is the figure, and the entryway systems. It might give you a better idea here after watching this figure. So the documentation is location and measurement of entryway system. You know, we have a limitation of the entryway system and their location. It should be in all on the functional entrances. List of room areas and exhaust rates and separation methods. Exhaust rates for where there could be hazardous gases, method and separation methods for interior cross-contamination protection. So the schedules showing MERV ratings in case you are going for the filtration strategy, and natural mixed mode design calculations as per the CIBSE reference standard. So whatever we have seen in the credit, or whatever strategy you are applying for, or what applies on your project, you have to submit the respective documentation. So this was option number 1. You can select both the option. This is the first, and you can go for option number 2 as well for another point. Option number 2 is additional enhanced indoor air quality, and there are strategies to implement just like the previous option we have seen, and it applies on the ventilation systems you are using in your project. So the first one that applies on both mechanical and natural ventilation system is exterior cross-contamination protection. We have seen interior cross-contamination by putting the entryway systems, grates and grills. This one is exterior, which is a bit more complex because it can be done by modeling, fluid dynamics, or wind tunnel modeling, tracer gas modeling, and to show that outdoor contaminants at intake are less than the thresholds. The second is mechanical, for mechanical ventilation system, providing increased ventilation above 30% than the required threshold. The more ventilation, the better, in the sense that the air is changed. So if you put 30% more, you're making sure that the air is not polluted, or there are no contaminants inside. If you remember, we put the CO2 monitoring in the natural ventilation because of the fact that with the breathing, the CO2 levels may get high. And with mechanical, it's not a prerequisite, because in mechanical system, air is being exhausted by your mechanical ventilation systems. But in order to put additional enhanced IAQ, you monitor CO2 concentration in all densely occupied spaces, and similarly it should also generate an alarm if it goes more than 10% by the set point. The fourth strategy is additional source control and monitoring. You provide one step ahead and evaluate potential sources of additional air contaminants besides CO2. You have put CO2 monitoring in place, and if you have any potential for other air contaminants, you put an alarm and you put the monitoring system for that pollutant. The final strategy here for enhanced indoor air quality, option number 2, is room by room calculations required for natural ventilation type. Chartered Institute of Building Service Engineers come again with the section 4 of AM10 for room by room airflow calculations. It has to be put in place as per the standard. So now the documentation is report showing contaminants levels. When you come to the exterior contamination prevention, list of densely occupied spaces, because you are putting CO2 sensors there, and if you are putting the CO2 sensors, you have to put the design calculations there, their location, and why you have put a certain set point. It has to be explained in your documentation. And the plan showing monitoring system. For natural ventilation, the one we just saw, CIBSE AM10 section 4, it has to be provided along with the calculations to fulfill the requirement of this credit. An exemplary performance of 1 point can be earned if you achieve both the option number 1 and option number 2, enhanced indoor air quality and additional enhanced indoor air quality strategies. This is to put things into perspective with a flow chart. And you can see that this credit enhanced IAQ strategies, you can see we have option number 1 enhanced, and we have further requirements with the ventilation type, mechanical, natural, or mixed mode. And you can go for both the option, or you can opt one option with additional IAQ. So this is a good way to look into the strategies and to the option and their relation in between. Prerequisite number 2, straightforward environmental tobacco smoke control. The intent is to minimize or to potentially reduce it to zero exposure of occupants, zero exposure of indoor surface and air system to any smoke, tobacco smoke. The requirement is to prohibit smoking indoors, zero tolerance policy. And outdoor should be allowed only in the designated areas, and these areas should also be minimum 25 feet away, not only from the entries but from any opening like any window or any air intakes. So you have to be 25 feet away, and there should be a signage of no smoking within 10 feet of all building entries. You can see the no smoking sign in the figure below, just like that. The residential projects and healthcare are exempted if comply with compartmentalization. For the residential, there is some legal issues because it is a home ownership. So if they can provide with certain compartmentalization, they're allowed. And also for healthcare facilities, there might be a situation where they have to allow the patient to smoke. For the school projects, it's zero tolerance all over. No smoking, even 25 feet away from the entries, not allowed. For the documentation, you have to provide the description of no smoking policy, including how it is communicated. It means by the photos, by the pictures, or by some document that you have distributed. Site plan showing designated smoking areas, if any, and their distance from main building entries or from the windows, if any, or from the air intake. And you have to show the signage photos. Credit number 2, Construction Indoor Air Quality Management Plan 1.4 all adaptations. Previously we have seen ESC plan, Erosion and Sedimentation Control Plan, and we have seen Construction Waste Management Plan. These plans were intended towards the environment. This IAQ is for the well-being for the construction workers and occupants by minimizing the air quality problems. The requirement is to implement the plan that protects absorptive material storage on site from the moisture. If the moisture is absorbed in the absorptive material, you know that it smells bad first. Secondly, some contaminants might be released in the air, which is not healthy for the construction workers or the occupants. Now, in case you are using the existing air handlers that are to be used in the project, and you are using them during construction, so all the return grills or the duct grills as per ASHRAE 52.2 should have a MERV 8 or minimum efficiency reporting value filter of number 8 on them, and it has to be replaced before the occupancy or before the final occupancy. So you are using a filter to protect the return duct, and that has to be changed before occupancy. And similarly, the smoking we have just seen, not only after the construction or building occupants or once the building is occupied, even before, during construction, it should be prohibited within 25 feet from the entrance. And the IAQ management plan should also follow SMACNA indoor air quality guidelines. This second edition 2007, and American National Standards Institute and SMACNA 008-2008. I know it gets boring when you have to reference so many standards. SMACNA is Sheet Metal Air Conditioning Contractors National Association. I'll give you a brief introduction what it deals with. Now, for the healthcare, it should implement environmental quality management plan instead of indoor air quality, and they should follow you know that in the healthcare the requirements are more stringent, so it follows SMACNA and 2010 FGI guidelines. So it should also comply with requirement of moisture we have seen, but additional VOCs, volatile organic compounds, outdoor emission, noise, vibration. You know that when it comes to the healthcare, LEED is extraordinarily cautious, extraordinarily stringent, and more taking care for the patients or the people who might be sick there. So we will see the SMACNA, what it deals with generally in the next slide. So for the documentation, you have to submit the IAQMP, Indoor Air Quality Management Plan, highlighting no smoking policy and all the other things we have just discussed for the absorptive materials, record of filtration media of MERV 8, and to change after once you are done with the construction before occupancy. And for healthcare, it should be environmental quality management plan. Just to have an idea what SmartNet guidelines deal with HVAC protection. The ducts and grills which are on site, they have to be protected from dust and any contaminants before they are installed, have to be covered to control any potential source that can pollute the air or contaminate the air. Pathway interruption, if you see in the figure that you cover the area where you are making any renovation or any construction activity. It also deals with the housekeeping and scheduling of works, that you schedule your works in a way that minimum occupancy is there at that particular time if it is possible. Credit number 3, indoor air quality assessment, 1 to 2 points except core and shell. Core and shell is exempted because the spaces are not finished even when the project is. So this credit deals with when the construction is finished and the building is yet to be occupied but cleaned, all filters are put in place, the workstations, furniture, everything is in place. Only then you have 2 options to go. The option number 1 is building flush out, and you have 2 paths to follow which are to be carried out under certain conditions. The temperature in which you are making the building flush out should be 15 to 20 degrees centigrade, and humidity should be no higher than 60%. Now the building flush out, the first one is before occupancy. The ideal one, in which building should be flushed out by supplying 14,000 cubic feet of outdoor air per square feet of gross floor area, and this is before occupancy. Now we will see it in the next slide, the formula if you are using the air handling units that are installed inside the project which supply the outdoor air for this flush out. It might take a bit more than you can imagine. We'll see it in the formula. So there is another path which is during occupancy, which you can do. You still have to achieve 14,000 cubic feet, but you can start 3 hours prior to occupancy and provide 3,500 of cubic feet of outdoor air per feet square of gross floor area, and continue during occupancy to reach 14,000 cubic feet. And the rate at which it should be supplied is 0.3 CFM per square feet. The documentation is that the flush out report must be submitted, including the total occupied area, because everything is going around the gross floor area. Should it be submitted? HVAC capacity, we'll see it in the next slide, how we can calculate the capacity, how much time it has taken for the flush out procedure, the log of dates, when it was done, what was the temperature, what was the humidity. You have to submit each and everything. So either you can go for this option or you can go for the second option. So these are the equations, 4 of them. Flush out outdoor air volume, the path number 1, straightforward, 14,000 CFM by area in feet square. For the second and third equation, in the during occupancy, the first one is 3,500, and to finish 14,000 you have to add another 10,500 after the occupancy. Now this is the flush out duration that I was talking about. In number of days it will come how? Area by in feet square, the gross floor area, times 14,000 CFM, to which you have to achieve as per the requirement, divided by the air handler capacity times 1440 minutes a day. 1440 minutes a day is 24 hours. So your air handler capacity, if it runs for 24 hours and it has to flush out the area with 14,000 CFM, if you do any exercise of from the study guide, you will be surprised to see that how many number of days are required. That's the reason they provide the path number 2, in which you can make this flush out during the occupancy. Now option number 2 is air testing. It will take, I think, more money or more funds are required, because you have to conduct baseline IAQ testing to show the maximum contaminant levels which are not exceeded, and you have to show that it did not exceed for formaldehyde, volatile organic compounds, carbon monoxide, following certain standards. And if they are exceeded, there should be a corrective action. It has to be done mainly in zone by zone or room by room, and if there are any corrective action that is to be taken, it should be retested in the same sampling location. So it will take more time, and that's the reason you will see that there are 2 points if you go for option number 2. Option number 2 does not ask you about occupancy rate, does not ask you about before or after occupancy. If you are able to show with the air testing, it's good to go. But there is money constraint here. So documentation is the reporting should include narrative describing procedures, the locations and dates of each result. If you go for both the options, you will get an exemplary performance of 1 point. Credit number 4, low emitting materials, 1 to 3 points for all adaptations. Intent and requirement seem similar to reduce the concentrations of chemical contaminants that can damage human health, air quality, and environment. So first we were taking out the contaminants in the air, interior cross-contamination prevention, exterior cross-contamination prevention, and now for the chemical contaminants. There are multiple options. Option number 1 for 1 to 3 points is product category calculations, and these are the categories. Following 7 should be 6 in fact, within allowable emission threshold. If you see, the 7th is the extra requirements for healthcare and school, which LEED is always taking care of. So these are the 6 categories. The first one is paints, coatings, adhesives and sealants, then furniture, flooring, ceilings, wood products, and exterior applied products. Have you ever wondered, all these 6 categories that you have seen, if in any building or in any office or in any situation you have entered where all these things are brand new, you might have smelled or you might have noticed there is a strong smell, and you can tell by this smell that these category products are new in nature. So this is where they can be emitting the emissions that we are talking about here. So we have a threshold and we have emissions and content requirements. These requirements are based on certain standards. So I guess that you can go through it and you have to remember the contents, threshold and their requirements. But in general, you have to remember these 6 categories, that these are the categories to which the options apply. You might have seen in the previous table that threshold shows VOC. Now what is VOC? VOC stands for volatile organic compounds, and these are the chemicals released in the air due to any plant-based, man-made or any natural material even, and exposure to high concentration of these chemicals may lead to chronic health diseases like asthma and even cancer. So this is the reason that LEED is focusing on VOC. We have seen VOC in other credits as well. Now in order to gain points, you can add the category with furniture or without furniture. It's up to the project team discretion. If they want to add furniture, then they will follow the number of points in the left table, and if they want to show the compliance without furniture, then they have to comply starting with 3 categories. So as per this table, it's with and without furniture, and school and healthcare projects have different compliance requirements. Now for the documentation, you have usually USGBC's calculator, minimum energy performance calculator. Here you have a low emitting materials calculator, and you should have the product information that shows the compliance with the thresholds that we have seen in the previous slide and the previous table. So third-party verification could be one thing to show compliance. Safety data sheet could be one, and testing reports that would be submitted for documentation. So this was option 1. Now we'll see the option number 2. Either we could go for option 1 or we can go for option number 2, budget calculation method, 1 to 3 points for all adaptations. Now if you have seen in the previous videos, the trend is that whenever the calculation comes in, things become a bit more details, or a little more effort is required for the credit compliance. Now here it's asking for weighted average of the calculation that includes VOC. We have seen how VOCs can affect the health, and we have to minimize as per the threshold, and they are targeting 6 assemblies here, starting from flooring, ceiling, walls, thermal and acoustic insulation, furniture and exterior applied products. So you have 6 categories here that are part of this budget calculation method, and you have to see the weighted average calculation for VOC information. And the good thing here is that you can go for the partial compliance. If 50% of walls are compliant, they can be joined with 50% of the compliant ceilings. And in total, after applying this formula, If 50%, more than 50%, and less than 70% products are compliant out of this 6 assemblies, you can get 1 point. From 70 to 90, it's 2 points, and more than 90 is 3 number of points. Documentation is similar to option number 1, emitting calculator, material safety data sheet for showing the compliance, or third-party verification and testing reports in the documentation. Exemplary performance can be earned when 100% compliance in option 1 or in option number 2. Credit number 5, thermal comfort, 1 point for all adaptations except core and shell, because the spaces are not completed in core and shell. The intent is to promote occupants' productivity, comfort, and well-being by providing quality thermal comfort. Now, thermal comfort can be achieved by considering 6 primary factors during both building design and operation. These 6 environmental and personal factors include surface temperature, air temperature, humidity, air movement, metabolic rate, and clothing. Although these factors are independent of each other, they contribute to an occupant's thermal comfort when brought together. So we have to consider both in design and in building operation. So in the design, the HVAC system and thermal envelope must comply with ASHRAE 55 2010, which takes into consideration these 6 factors. Or for international projects, they could go for ISO 7730 2005 and EN 15251 2007. So the control requirement is that it should be provided for 50% of individual occupant spaces like personal offices and others, and 100% of combined occupants like an open floor area for workstations that allow occupants to at least adjust one of the following: air temperature, air speed, humidity, and radiant temperature. And there are certain control measures that qualify that we are going to see in the next slide. So we know that there are 6 factors based on which the design has to be made, and these are the controls that are to be provided. At least one of these controls should be provided. We'll see what are the acceptable controls. So the first one is thermostats, but it should not have a fixed set point. If you fix the set point for the thermostat, it kills the idea of any control. So thermostat without fixed set points, ceiling fans is one of the acceptable control, adjustable underfloor diffusers, and task-mounted controls like humidifiers for humidity and operable windows, etc. Now there are certain exceptions for healthcare, because in healthcare each patient room should have separate control. It cannot be the same as what we have seen in the open area workstations. Each patient might need different temperature and humidity, etc. So he should have a separate control. For retail, it applies to only office areas, and for data centers, it applies to regular occupied floor areas only. Now for the documentation, you have to submit the narrative describing design strategy based on the 6 factors we discussed, with description of weather data that determine operative temperature, humidity, and outdoor temperature, and the verification of the standard you have followed, that you have complied to the standards. List of spaces type, because it depends on the individual occupant space or multi-occupant space, and the quantity and control is to be provided for documentation showing your compliance. Credit number 6, interior lighting, 1 to 2 points for all adaptations, and the intent is to promote the productivity of the occupants by providing quality lighting, considering in mind the comfort and well-being. And in order to fulfill the intent, we can go for either option number 1 or option number 2, or we can go for both the options and gain 2 number of points. So the first one is to provide lighting control for 90% of the individual occupant spaces. Any space that is occupied by a single occupant, or intended for a single occupant, like a private office, it's 90% of the controls should be provided. And it should be provided for 100% of the combined occupant spaces like open area workstations. There should be a lighting control. It should not be a single on and off, but it should be 3 levels of control: on, mid, and off, where mid could be anywhere from 30 to 70% of the maximum capacity. Any areas like presentations or projections, these area lights must be separately controlled regardless of their occupant density. Now the documentation, table of individual and multi-occupant spaces, and controls that you have provided for each space. Just to stress once again that the levels should be 3 and not 2. The second option is lighting quality, and it has it has to meet 4 out of 8 offered strategies. Let's have a look what are these strategies and what they offer. So these are the offered 8 strategies. We can go through them one by one. You can also read them. Let's quickly go through 1, 2. The first one is the light fixture luminance, to use fixtures less than 2500 candela per meter square, and color rendering index called CRI should be 80 or higher. Lamp life should be at least 24,000 hours. I think you can pause the slide and go through it, and we have to comply with either with any 4 of them in order to gain 1 point in the lighting quality. Now when it comes to the documentation of option number 2, things become a little bit tricky in the sense that you have 8 strategies and different requirements are for different strategies, and some requirements or some documentation requirements overlap and they can be submitted for more than one strategy. For example, table of regularly occupied space and lighting controls can be provided or should cover for option number 1 and 4, that is light fixture luminance and direct only overhead lighting. Similarly, lighting details and results of estimations can cover the documentation for 1, 2, 3 and 4th category. And similarly, average surface reflectance documentation will cover 5th and 6th category. And similarly, we can see that the other documentation that are required for different strategies. Credit number 7, daylight, 1 to 3 points in all adaptations. The purpose is to introduce the daylight or the sunlight into your spaces. Now you have to agree with me how it does not matter how good you have put your task lighting, your overhead lighting, your hidden lighting, nothing tops as in feel than the sunlight or the daylight. It feels good, and also it helps you offset your electricity costs in the sense that if you have daylight illuminating your space, you do not need any artificial lighting. But also for the requirement, if you remember from lighting pollution, glare is an issue, so you have to control glare here. Also, you have to provide manual or auto glare control devices for all regularly occupied spaces. The auto system should also have a manual override. And what could be the glare control devices? You can have window blinds, shades, curtains, exterior louvers, screens and movable awnings all qualify for the glare control devices. Now for the option 1 to gain 2 to 3 points is spatial daylight autonomy. You have to demonstrate, this is via simulations because your building is not yet made, so you make the simulation on a computer software and you have to show that SDA, spatial daylight autonomy, of 55 to 75% of regular occupied floor area and annual sunlight exposure is no more than 10%. Now let's see, what is spatial daylight autonomy? It's a metric that shows what portion of space receives sufficient daylight. And this you can show by, as we know, through the computer simulations. And for the annual sunlight exposure, it's again a metric that shows how much of a space receives significantly more than sufficient direct sunlight. So you have sufficient daylight, and the other metric is that shows more than sufficient direct sunlight. And based on the table below, 55% will give you 2 points and 75% will give you 3 points. For healthcare, a little change, that in this case it's instead of regularly occupied floor area, that's going for perimeter floor area. Since our percentages were based on regularly occupied areas, so you have to show the plans which specify these spaces and the list of glare control devices, whatever you are using, and what are their control, manual, auto, with manual override, and a narrative describing daylight simulation, inputs and weather file. There are lots of input that you have to put inside the simulation software, so you have to provide the narrative describing all of that. This was the first option, and you can go for another option, and the relationship between the options is or. Either you go for option 1 or you go for option number 2, which is illuminance calculations, and it is going to give you 1 to 2 points. This also is based on simulation, not actual. So you have to demonstrate via simulation that the levels of illuminance will be from 300 to 3000 lux, from 9 AM to 3 PM of 75%. If it covers 75%, then you'll gain 1 point, and if it is 90%, you'll gain 2 points for regularly occupied floor area. So the previous one was also based on regularly occupied floor area. The second one is also based on regularly occupied floor area. There was simulation there. There is simulation here, but here we have the lux level from 300 to 3000 and the restriction from 9 to 3. And you have to exclude blind or shades from the model because you have to see the actual coming in. Now the documentation is in addition to the above documentation for option number 1, list of compliance spaces with their calculated luminance values. This was the option number 2. The first two were based on the simulation. The third one is based on actual measurements. So this is called measurements 2 to 3 points, and for healthcare it's going to give you maximum 2 points. The illuminance levels between 300 to 3000. So the requirement is kind of similar to the option number 2, but this is based on simulation, this is based on actual, and it must be achieved for either 75 or 90% of the included floor areas. And in this case, since it's actual, you have to show the measurements that are taken by the actual light meter. Since option number 3 is based on actual measurements, so it is typically pursued by renovation projects, and as per the requirement of option number 3, the measurements should be taken at not 1 point but 2 points or 2 intervals. The first one at the construction completion or the renovation completion, and second at least 5 months from first measurement. So this is the table that shows if you have taken the first measurement in January, February, then you can take the respective second measurement from the second column of the same table, and based on that, if you are able to show 75 or 90%, you will gain 1 and 2 points respectively. For the documentation, floor plans highlighting regularly occupied spaces and the measured illuminance values for each node and calculations which demonstrate the compliance, and you have to also submit when the first measurement was taken and when was the second measurement taken, and it should comply with the table shown in this slide. Credit number 8, quality views, 1 point for all adaptations. For healthcare, up to 2 points. The intent is to connect building occupants with outdoor environment by providing the quality views. But why? A great deal of literature indicates significant benefits to patients and staff, improved learning experience for students, and increased productivity for workers who have greater access to daylight and quality views. Views of parks, green roofs, walls, nearby buildings, pedestrians, vehicle movement, all are example of quality views. So what we can see in the requirement number 4 as well. View that includes from flora, fauna, sky, movement, objects. These are all examples of quality views. Now, to fulfill the intent, the requirement is to achieve a direct line of sight, unobstructed view, of outdoors via vision glazing for 75% of all regularly occupied floor area. Now, this can be challenging because maintaining views for spaces near the building core is a problem. One successful strategy that has been implemented in all the previous LEED projects is to locate open plan areas such as open workstations at the perimeter while placing private offices and unoccupied areas near the core of the building. Another strategy could be using glass partitions for perimeter offices in order not to block views and daylight. So by applying these strategies, we can achieve this 75% vision glazing of all regularly occupied floor area. Now the requirements are: fourth, we have already discussed 2 out of 4 types of views. Number 4, we have seen multiple lines of sight at least 90 degrees apart, unobstructed views within 3 times head height, straightforward. View with view factor of 3 or more. We're gonna see the view factors in the next slide, but just for the definition, measure of amount and quality views within a cone of vision from a workstation. Let's have a look at the view factors. What are they and how many are they? As per the definition, we know what it is. We have 4 requirements to fulfill, and now we know at least some of the strategies that can be implemented to achieve the main requirement to have a direct line of sight of outdoors via vision glazing. So these are the view factors we have just talked about. The further you are, the more the obstruction, smaller is the number, the closer you get without the obstruction, greater is the number. If you recall the figure that we have seen in the previous slide, it had a view factor of 5. So as per the requirement, the view factor of 3 was minimum required from these 4 options. Now this all can be done if you put all these things into consideration at the design phase. The closer you get to the construction without having these things in mind, it would be harder to incorporate in the design later on. So for the healthcare, if you remember, there are 2 points. So the first one is the 75% of regularly occupied area is only for the inpatient units. The rest of the requirements remain the same and you can gain 1 point. But the extra point comes if you meet the requirement of 2 view types out of 4 that we have seen for the perimeter area, and it's going to give you another 1 point. So for healthcare, there are 2 points. For warehouse and data centers, the regularly occupied area or the offices criteria in these 2 adaptations remain the same. However, for the storage, sorting, and distribution area, you can meet only 25% of area that fulfills the 2 of the 4 options that we have discussed. Instead of 75, it is now 25. But for the offices, the requirement remains the same as new construction. Now for the documentation, since it asks you for regularly occupied areas, so you have to submit the floor plans and qualifying floor area, what kind of view type you are designing for this space, you have to submit, and drawing, rendering, and photos that indicate line of sight. Now this drawing and rendering, of course, will be in the design phase. So if you have put it in the design, it will be easier for you to submit for the documentation. Now for the exemplary performance, you can earn 1 point when 90%, instead of 75, you go for 90%, you can earn an extra point. And in warehouse and data centers, if in the storage areas, which is 25% as per the requirement, if you go for 50%, and you can achieve 1 point. And for healthcare, if instead of 75, you go for 90% for inpatient units, you can achieve 1 point for exemplary performance. PR number 3, minimum acoustic performance for schools only, and the intent is to provide the classroom that facilitate communication through effective acoustic design. Now we know, and I have stressed it so many times in other videos also, that when it comes to schools and healthcare, LEED is extra cautious and the measures are more stringent. So if you see the acoustic performance, there is a credit as well, but for the schools, it's a prerequisite. Why? In normal circumstances, if you have any background noise coming, and if you have any echo in the room, it's uneasy, it's really annoying. So in facilities like school, where you have to teach the students, and the communication is the key, and you should not have any obstructions, so this one is not acceptable at all when it comes to the LEED standards, and that's why they put it as a prerequisite, and they put these requirements for fulfilling the intent. That is to control 3 types of background noises. The first one is HVAC noise, means any noise that your equipment of heat, ventilation, air conditioning makes. The exterior noise, that is coming from the outside. Reverberation time, which is basically echo, how long it's there, and before, or how much time it takes for the echo to go away. So for the classrooms greater than 20,000 cubic feet, they must be designed as per certain standard. NRC, CNRC, Tech Update number 51, and classroom with volumes less than 20,000 cubic feet must be designed to include sufficient sound absorptive finishes. Why? Because if the classroom is smaller, then there is much more chances of echo coming back. So the sound absorptive finish should also be as per the standard of American National Standards Institute as 12.602010. Now let's have a look at this HVAC noise, exterior noise, and reverberation time. We have discussed about it. The requirement for HVAC is it should not exceed 40 decibels as per the standards, and equipment location can help reduce noise in the classroom. How could this be achieved? If the equipment is inside the classroom, definitely the sound of equipment can be felt inside. If you can place the equipment, which is the usual practice, even in the houses, the people who are familiar with design, you usually put your equipments either in the corridor, or you put it somewhere in the kitchen, or in the bathrooms. You do not put it in the bedrooms if they are centralized equipment. So this is one strategy that you can avoid the background noise of HVAC by placing it in the areas where the communication, or it's out of classroom. So now when it comes to the exterior noise, team can implement sound sealants, windows and door gaskets, acoustic glazing, barriers. These are all the strategies or something that you can do in order to damp the exterior noise and in order to fulfill the intent of this prerequisite. Now have a look at this reverberation time. Technically, it is the time required for level of steady sound to decay 60 decibels after the sound has stopped, means the time it has taken for the echo to go away. And we have seen in the requirement that we can revisit the room size as per the strategy here. We saw in the requirement that for certain 20,000 square cubic feet, beg your pardon, volume, the classrooms have to follow certain standards for absorptive finish. So this is how you can deal with the reverberation time. If you see in the figure, it gives you the idea of all types of noises. You have exterior noise coming from the bus, any rain or lightning, it can produce also exterior noise. And if any kids are playing outside, these are all background noise, background exterior noise that are coming from the outside. Then the HVAC noise, the light noise, these are all internal noises, but also plays a part, and these are to be avoided. And with the strategies we have already seen, echo or reverberation time we have discussed. Now for the documentation, you have to submit the summary of the report of the background noise, how you calculated them, what were the exterior noises that you have encountered and how you tackle them, and a narrative describing the measures. So the calculation showing that reverberation time, for the third one we have discussed the exterior and we have discussed the other HVAC. Now the calculation showing that reverberation time standards are being met for the respective volumes of the classroom size. Either it is greater than 20,000 cubic feet, or if it is less than 20,000 cubic feet, and the respective standards are being met. Credit number 8, acoustic performance, 1 point for all adaptations, and for healthcare 1 to 2 points. Core and shell is taken out because it does not have finished spaces. Now there are so many technical terminologies, and this topic is a bit detailed, but I'll try to minimize and try to compact it as much as I can. The intent is almost similar to the previous one, but in that case, since it was a prerequisite for the schools, it said that provide classroom with the that facilitate communication. Here it is to provide spaces that facilitate communication through effective acoustic design. Now the first one, the requirement is to achieve background noise as per AHRI standard for HVAC, which is the heat ventilation air conditioning. We have discussed what it could be, and there are some strategies to avoid as well. To meet composite sound transmission class ratings or local equivalent. Now this, what does it mean, sound transmission class? It's a rating which is a rated value of the capacity of a partition to attenuate airborne sound. It is calculated by averaging the transmission loss through an entire assembly. And we know that sound has a tendency to travel through the weakest element, so the penetrations or openings in the assemblies may need to be specified with a higher sound transmission class rating or STC rating, and they are typically reported by the manufacturers. And you have to eliminate background noise by reducing sound transmission and echo and improve indoor sound characteristics. So the purpose is to eliminate the noise and echo and anything that can hinder in proper communication. That has to be avoided and to be designed as per the standards. Now when it comes to the large conference rooms and auditoriums, They must evaluate first whether sound reinforcement and audiovisual capabilities are required or not, and if they are needed, they have to be under certain standard. And for masking system, design levels must not exceed 48 decibels. Now, what is sound reinforcement? What is masking system? We have to understand. Sound reinforcement is typically considered for meeting open office, public or presentation spaces that seat more than 50 people. So first thing, more than 50 people depending on their function. Simple amplification system may meet the criteria for smaller and simpler spaces. And sound masking is a technology that uses artificially produced sound, such as white noise, to cover or mask unwanted sound. Sound masking helps eliminate awareness of pre-existing sounds in a given area and can make occupants more comfortable and productive. So this is trying to cover another sound you produce, a masking sound. So in that case, if you are producing a sound, a white noise, which is under the masking system, the design levels must not exceed 48 decibels. So as I said, it's a bit more complicated, but I'm trying to simplify as much as I can. For school, HVAC background noise for the credit, there is for prerequisite, and for the credit, it should not exceed 35 decibels, and they should all the classrooms and learning spaces must meet ANSI, American National Standards Institute, S12.60 2010 standards. And the HVAC unit placement we discussed in the prerequisite as a strategy that it has to be placed in corridor or storage spaces to reduce noise, and exterior windows with sound transmission class rating of at least 35 should be used unless you can justify if you're using less sound transmission class rating. We have seen what it is. So this is acoustic performance requirement for the new construction, major renovation, and schools. So we know that LEED is more stringent for healthcare also, so there are furthermore requirements for healthcare. Let's have a look at them. For healthcare, there are two options to choose from. I think when it comes to the background noise, this type of adaptation, the healthcare facility, is the most important one. All around the world, in some places, schools are also considered, but unanimously for the hospitals or the healthcare facilities, you cannot even honk outside these facilities because there are patients inside. So when it comes to the background noise, this is the most important adaptation. The first one is to achieve speech privacy, which is you should have a private sort of area where you can discuss the confidential talks about the patient illness and something else that is private, acoustical comfort, and minimal noise by sound isolation. So you have to isolate the sound from where you have all these things going on. How it can be done? By improved partition assemblies that have better STC ratings and absorptive room finishes. Background noise by MEP systems should be designed as per 2010 FGI guidelines in interior rooms and spaces, and sound levels should be calculated. Not only design, but also calculate if it is working as per the design or not. It should be complying with this standard. So this is option number one. The second one is acoustical finishes. Specify materials, product, system installation details, and other design features to meet 2010 FGI guidelines. For example, in the figure, if you see, this is acoustical louver. It is designed to cover all the MEP system. It allows the air to go inside. It's nice to look at, and it dampens the noise that the MEP systems are generating, and hence providing sort of sound isolation for the people inside. The average absorptive sound coefficients should be calculated to confirm conformance. Now, the general idea is, as we have seen and discussed, that you have to isolate extra sound, or you have to eliminate the background noise because this is essential for a healthcare facility. After acoustical finish, we have side exterior noise, which is kind of self-explanatory to minimize exterior sound effects. But these are also classified into 4 categories, which is to measure and analyze data to determine this exterior noise. This is A, B, C, and D, the classification of the facility site. And I'll leave up to you to have a look, to search, or to check it in the study guide. Now, we have seen that for the new construction, major renovation, and other adaptations, you can earn maximum 1 point. But for healthcare only, you can either choose option 1 or option number 2, or you can go for both the options to gain 2 points. Now, for the documentation for major construction and major renovation and new construction, the sound level values, narrative of measure for measurements, how you actually achieve them, the sound transmission class ratings, and list of relevant rooms. And when it comes to the conference room and auditoriums, if you have used any masking system or reinforcement system, you have to submit it as a documentation. For the healthcare, in addition to relevant documents up for a new construction, you have to also submit the privacy index values if you are going for option number 1, and if you're selecting option number 2, site noise exposure classification, narrative, which I have left up to you if it is A, B, C, or D, and the mitigation you have applied for by following the standards for exterior noise classification. By this, we come to the end of this credit category, and I hope you'll continue to the next video. Thank you.